So hey guys, my name is Aman Muleva and today we are going to discuss about nearest neighbor classifier and it is a topic from data mining and data warehousing. So what is nearest neighbor classifiers? Nearest neighbor classifiers, often referred to as k nearest neighbors, are a fundamental and a widely used techniques in the realm of data mining and data warehousing. This approach leverages the concept of proximity to predict the class or category of a new data point. In essence, KNN algorithm identify the k closest data path to the point in a new dimensional space based on the chosen distance metric. The majority class among these neighbors is then assigned as a prediction for the new data point. The genesis and evolution of KNN. The KNN theorem was first published by Bayes as a Bayes theorem, and since then it has been upscaled till 2018. The genesis and evolution of KNN, the early roots, the foundational principles of K-nearest classification can be tracked back to the early days of pattern recognition research. The concept of finding similar patterns or objects based on the proximity was explored in various fields, laying the groundwork for the development of KNN algorithms. Formalization and refinement. In 1960s witnessed the formalization of KNN algorithms with researchers like Evelyn Fix and Joseph Hodges establishing a rigorous mathematical framework for the technique. The concept of k neighbors, signifying the number of nearest data points considered, was introduced during this period. In data mining. Within the advent of data mining in the 1990s, KNN algorithm found widespread application in various domains, including customer segmentation, fraud detection, and medical diagnosis. These applications leverage the ability of KNN to effectively handle large datasets with uncover hidden patterns. Distinctive features of KNN. Simplicity. KNN algorithms are renowned for their simplicity both in concept and implementation. They acquire minimal assumption about the data distribution and can be readily applied to various datasets without complex parameter tuning. Versatility. KNN is a versatile technique that can be used to both classification and regression tasks, making it valuable tool to diverse data analysis needs. Non-parametric nurture. KNN is considered a parametric method, meaning it does not assume a specific underlying distribution for the data. This flexibility allows KNN to effectively handle complex and irregular shaped patterns. Sensitivity to noise. While KNN offers simplicity and versatility, it is susceptible to noise in data. The presence of noisy or outlier data points can significantly influence the classification results, requiring careful pre-processing or noise reduction techniques. The core of KNN, the model layer. Data representation. KNN algorithms operate on a dataset where each data point is represented as a vector in the multidimensional space. Each dimension corresponds to the feature or attribute of the data, and the values in the vector represent the measurements of each feature for a particular data point. Distance metrics. The selection of a distance metric is crucial for determining the proximity between data points. Common metrics include Euclidean distance, Manhattan distance, and cosine similarity. The choice of metric depends on the nature of the data and the specific problem domain. Nearest neighbor search. The core of KNN is finding the k nearest neighbor to a new data point based on the chosen distance metric. Efficient algorithms for nearest neighbor search for essential, especially when dealing with large datasets. KNN in action. The admin interface. Visualization and exploration. The well-designed admin interface for KNN provides users with intuitive visualization and tools to explore the data. This includes scatter plot, histograms, and other visual techniques to gain insights into the data distribution and relationships between features. Model configuration. The admin interface should enable users to easily configure the KNN model, including selecting the value of K, choosing the distant metrics, and defining the feature used for classification or regression. Performance evaluation. The interface should provide tools for evaluating the performance of a trained KNN model metrics such as accuracy, precision, recall, and F1 score are essential for assessing the model predictive capability. Navigating data, URL routing in KNN, request handling. URL routing plays a critical role in managing incoming requests and directing them to the appropriate KNN model or functionality. This routing system maps URLs to specific views or controls responsible for handling the request. Data retrieval. Once a request is received, the routing system retrieves the necessary data from the data warehouse or data source. This data is then processed and prepared for use by the KNN model. Model execution. The retrieved data is passed to the trained KNN model for execution. The model performs the nearest neighbor search and returns a predicted class or value based on the input data. Presenting presenting results. The template system in KNN. Data visualization, presenting the predicted result in a clear and informative manner, often using charts, graphs, and tables to visualize the relationships between features and prediction. Model summary, displaying essential information about the trained KNN model, including the value of K, the chosen distance metric, and the performance metrics. Interaction, providing interaction element that allow users to explore the results, filter data, and modify model parameters. Streamlining interactions, form handling, and KNN. In KNN, user output, user input. Form handling enables user to input new data points for prediction. The form should be designed to capture the relevant features and ensure data integrity. Data validation. The validation ensures that the input data meets specific criteria, preventing errors and ensuring that the KNN model receives valid data for prediction. Model execution. Once validated, the input data is passed to the trained KNN model, which performs the classification or regression task and returns the predicted results. Output presentation. The predicted result is then displayed to the user in a clear and concise format using appropriate visualization techniques and providing additional context as needed. Enhancing KNN, middleware and signals. Middleware in KNN can be used to implement cross-cutting concerns such as authentication, authorization, and logging. These concerns are applied to requests before they reach the KNN model and after the model has generated its response. Signals provide a mechanism for decoupling components in the KNN system. They allow different parts of the system to communicate with each other without direct dependencies, facilitating code reusability and extensibility. The future of KNN, advances and directions. Large-scale KNN. Research is actively exploring techniques for scaling KNN algorithms to handle massive datasets, leveraging distributed computing and approximate nearest neighbor search algorithms. Hybrid KNN models, combining KNN with other machine learning techniques such as deep learning and assemble methods, holds promise to improving the accuracy and robustness of the KNN model. Interpretability and explainability. Efforts are underway to enhance the interpretability and KNN prediction, allowing users to understand the factor contributing to a particular prediction and gain insights from the model. Thank you.